Now we're going to find out if Marty will make it back to the future. Well, maybe we won't really, but we're going to use his car as an example for the empirical rule. So after accelerating for 20 seconds, a DeLorean sports car has a wide range of speeds that it can achieve depending on traction. The distribution of speed follows an approximately normal distribution with a mean of 80, so that's super important right there, mean of 80, and a standard deviation of 7.7 miles per hour. So we want to label the appropriate values on the normal distribution. So going back, and we're again using the empirical rule. If I go way back to the empirical rule, you remember all this and all that. And in the notes, I think it was page, what page? Oh, here we go, right there. So I pretty much am going to label it kind of like this, all right? And if I go back to it, what is the page, 23 or 21, somewhere around there? Go fast. There we go. So I label it, and it looks something like this. So there's my different values. The mean, I could probably center that better, is right there. And then I have 87.7. I keep adding the 7.7 to go up in values. All right. So this is really just reviewing the empirical rule. All right. So this is what percentage of runs will give the DeLorean a speed greater than 87.7 miles per hour? Well, there you go. What percentage of runs will give the DeLorean a speed between 64.6 and 87.7? Well, there you go, from here to here. So you got this yellow slice, these three slices right here. You add them together and it gives you the value. Less than 64.6, so I have to add these two green slices and I get, oh, I dropped a half, 2.5%. And then they said 68.45, which is right about here. And it doesn't seem to line up well. It's about 1.5 standard deviations below. We really can't do it using the empirical rule. So what we're going to have to do is we're actually going to have to use the actual normal model and technology. So when I used to do this, we'd be given a horrible table, and we'd have to add the pieces together because a table would give us pieces as well. Sometimes we'd have to subtract pieces. But luckily, with technology, I can go ahead and set it up. So you can see here that the normal model is a mean of 80 and 7.7. So let me go ahead and go to normal distribution right there. A mean of 80 and 7.7. And what's kind of cool, have you noticed it draws out your empirical rule for you? All right. And it wants to know what is the probability or what percentage of runs will give a speed less than 75 miles per hour. So all I have to do is make sure that I'm going to the left of a value and put 75 in, calculate, and if you click this show labels on plot, you get this beautiful picture right here, and it gives you the area. You can change that to percent. You could say 25.81%. But most of our answers are actually in decimal format. So that's how I got the 25.81%. Then I asked what percentage of runs will give the DeLorean a speed greater than 85 miles per hour. So the greater than, you go to the right of a value, make sure you put in the right value, hit 85, calculate, and voila, same answer. Why is it the same answer? Why do I have 25.81% here and 25.81% there? Well, 75 is 5 miles per hour below 80, and 85 is 5 miles per hour above 80. 80 is our mean, and it's our center, so these are symmetric. So it should be the same, because it's cutting off pretty much at the same area, same distance from the mean on both sides. Number 8, what percentage of runs will give the DeLorean a speed of between 70 and 95 miles per hour? So you go to your normal distributions, and now you can say between two values. I think it was 75. What was it, 70 and 95 or 70 and 95? It's like I thought it was 95, but I knew one of them didn't end in 5. And there you go. There's your area, 0.8773 or 87.73%. All right. Now on the check for understanding, I didn't really have you fill that out. You were fine. What percentage of elephants produce between 250 and 300 pounds of waste a day? So we need to know the mean. The mean is 250. There you go. And the standard deviation is 21. There it is. You go back to your normal distribution. You do 250, 21. Plot the distribution. It changes now. And we want 250 to 300. So I say 250 to 300. Calculate area. And there I get 0.4914 or 49.14%. You can see on when I created this one, I was set on percents. Right now I'm on decimals. Decimals is the better option. And then finally, they ask you what percent of elephants produce more than 250 pounds of waste in a day. Well, if the mean is 250, that's a halfway mark. So you don't even need to use Statlet for that. 50% of elephants produce more than 250 pounds a day. So that's it.